So today we're starting chapter 8. We're doing section 8.1. It's all about classifying polygons. So our objective is to describe polygons in various ways. After we do 8.1, we'll do 8.2 on Wednesday and Thursday, and then Friday we'll finish up with 8.3. You have a quiz next Tuesday, so next Monday is a review. Quiz on Tuesday, and then we'll continue with the chapter. So we're going to start with some definitions for today. Here's your first one. Give you guys a couple minutes to write. You can draw the picture as well. It's actually the same picture. This one just has the sides extended, so you can pick either version and write it. So a convex polygon basically means that if you extended the sides, none of those lines would go through the figure. So I'll show you on that first one. If you look at each side and keep it going, that's how they came up with the second figure. None of those lines would go into the interior of the polygon. That means it's convex, okay? Another way that I like to think about it is, these are called the vertices, or a vertex is the singular. None of the vertex are pointing in. They're all pointing out. So like the corners of the figure are all pointing out. That means it's convex. Yeah, the 5th triad actually ends this week, so we're getting there. Any questions on convex? It should actually become a little more clear once you see the next definition. Sort of the opposite of convex when you guys are ready. Concave is the opposite of convex. So if it's not convex, it's concave. Meaning that if you extend any of the sides, the lines that you're drawing would end up inside the figure. So do you see how these are sort of pointing inward? That's concave. I like to think of it as like if you pushed on the sides, they would cave in on each other. Like if you put your hand here and pushed in, the figure would cave in. That's concave. Or you could think of as the corners are sort of pointing in. So if it would cave in on itself, it's concave. Any questions on convex versus concave? So these definitions are pretty self-explanatory, very similar to when we talked about triangles. Equilateral just means that all the sides are congruent. So if all the sides are the same, we call it equilateral. Equiangular means all the angles are the same. And then if it's both, it's called a regular polygon. So if all the sides are the same and all the angles are the same, then you just say regular. Any questions on these definitions? Alright, here's some examples, so I'll give you a second to sketch these. First we're going to talk about convex versus concave. So back to those first two definitions you wrote. It's one or the other. So like I said, go ahead and sketch these so you have them in your notes. They don't have to be perfect. Remember, if any of your vertices are pointing in, then it's concave. Or if the figure could like collapse in upon itself, concave. If not, it's convex. So what do you guys think for number 1? Do you see anywhere where it's pointing in? Or if you're unsure, extend all the sides and see if any of those lines go into your figure. Do any of them? Yeah, do any of them point in? Would any of them cave in? No, so this is convex. When they're all pointing out, it's convex. What about number 2? Look, if I extend these sides, they're going into the figure. So this one is concave. Good. It would cave in on itself. Concave. What about number 3? Those are going in. This one's also concave. And number 4? Concave, good. Try to trick you. So the only one that's convex is number 1. The rest are concave. Any questions on these? Everyone understand the difference? Everyone awake from spring break? Alright, here's our next 3 examples. I'm going to add a little bit to the directions. So it says decide whether the following polygons are regular. I'm going to add a little equilateral or equiangular. We can go a little farther than just regular. So remember, regular means all these angles are the same and all the sides are the same. If only the sides are all the same, then it's equilateral. If only the angles are all the same, then it's equiangular. All right, example 5, what do you think? Regular, equilateral, or equiangular? Are all the sides the same? Are all the angles the same? So when it's both, what do we call it? Just regular, good. All right, number 6, sides, angles, or both? Angles. The angles are the same, so we call it equiangular. And then number 7, sides angles are both. Just the side, so that's equilateral. Good. Any questions? Alright, here's example 8 and 9. So the directions say that these polygons are all equilateral. So I know that all the sides are going to be the same. We're supposed to find the perimeter. So as you're writing these down, see if you can remember what that means to find the perimeter. Yeah, the perimeter means you add up all the side lengths. So like in number 8, what are all the side lengths? They're all 9, so you can label them all 9 if you'd like. So you have 2 options. You can do 9 plus 9 plus 9 plus 9 plus 9. What's another way to do that? Multiply 9 by what? 5, because there's 5 nines. Either way, what do you get for the perimeter? 45 centimeters. Good. So however you want to do the math, that's fine with me as long as you come up with the right answer. What are all the side lengths on number 9? 7. So you could add 7, 7, 7, and 7. Or you could just multiply 7 by 4. Either way, what's your answer? 28 feet. Very good. Make sure you're labeling these. If they give you a unit, use it. What are your questions on 8 and 9? Give you a second to catch up. We went through those pretty quickly. Alright, here come the last 2. So we're going to solve some equations. The definition of regular is something that you definitely need to know here. What does it mean to be regular? Can someone remind me? Yeah, it's equilateral, so all the sides are the same. It's also equiangular, so all the angles are the same. So if all the sides are the same, how could I start number 10? Ideas? The sides are the same. What am I going to do? What's another way to say the same in math? No, that's the opposite. Equal. You can set them equal. So 21 must equal 5x minus 4. And then you can just solve that to find x. So you add 4 to both sides. So 25 equals 5x. Then divide both sides by 5. I heard someone say it already. You're going to get 5 as your solution. Good. And then you could always plug it in to check. If you plug that in, you'd have 5 times 5, which is 25, minus 4, which is 21, and 21 and 21 are the same. Good. So on number 10, we use the fact that the sides are the same to solve it. Number 11, we're only given information about the angles. What's so special about the angles? The angles are... Oh, it's convex, yeah. But we don't need to know that for this one. We just need to know that the angles are the same. Very good. The same in math class means equal. So I'm going to set these equal to one another, and then I'm going to solve. How do I solve this one?
Add 2.
Add the 2. Good. So you have 11x equals 110. And then you divide both sides by 11. So what do you get for x? 10. Very good. What are your questions on section 8.1? All right, here comes your homework.